Assalamualaikum. So we are from Group 5. We will be presenting about biomass power plant, empty fuel from palm oil. So we are Group 5. We are consist of 4 people. It's me, Aidil, Zahrul, one Irfan, and Hadik. Next.
Abstract. During the process of producing palm oil, a type of biomass known as an empty front goods is created. Due to increasing production, EFB that was previously disposed of as garbage is now utilized as fuel. The high moisture content of EFB frequently lowers the combustion temperature and decreases energy efficiency. Therefore, when developing an EFB power plant, the drying process should be considered. In this work, we stimulate a process for a 5 megawatt power plant that includes the drying process and contrasted the optimized energy efficiency with an existing method. By considering the temperature, time, flow rate, and essential moisture content of the drying process, we were able to determine the EFB ideal moisture content. EFB moisture content was 7.79% at the optimum point, and efficiency has increased by 14.29%. Objective. First, to investigate the current technology of renewable thermal energy available in the market over the world. Second, to design and range 5 kilowatt to 10 megawatt of power plant using renewable energy. Third, to study the potential of renewable energy in Malaysia. Problem statement. Energy demand in Malaysia is increasing yearly up to 7% per year, while 40% of the energy is supplied from conventional fossil fuel. Sustainable Development Goal 7, SDG 7, main concern is to affordable, reliable, sustainable and modern energy for all by 2030. Its 3 core targets are the foundation for our work. Ensure universal access to affordable, reliable and modern energy service. However, a number of social barriers have slowed down the social acceptance of renewable energy among the public in Malaysia. Where it originated in West and Central Africa as well as in Malaysia, Indonesia and Thailand, where it predominates, thrives regionally and has long since established itself. Oil palm is widely grown as a source of oil. The rapid growth of oil palm plantations in various areas as a nation has produced massive amounts of vegetable waste, complicating replanting efforts and raising serious environmental concerns. Thus, agricultural waste produced by the oil industry during replanting, pruning and milling operations is referred to as oil palm biomass and is typically left to degrade in the field. In essence, fibers from empty fruit bunches are either left over after the extraction of palm oil from palm fruits, cultivated materials, or the carcasses of trees that have reached the end of their useful life. The waste are typically dumped carelessly or utilized as fuel by the residents for cooking, neither of which is environmentally friendly. The fruit bunches are removed from the oil extraction process and left unfilled as leftover. Although the presence of these empty fruit bunches, EFB, at the mill's gate cannot be avoided, waste management and disposal solution must take into account the enormous difficulty that this biomass waste give mill management.
Theory of Rankine cycle. So an example of biomass produced during the process of producing palm oil is the empty fruit bus, EFB. EFB, which frequently contain a lot of moisture and is disposed of as garbage, has slightly become more prevalent and is being utilized as fuel. By using EFB of palm oil, the organic Rankine cycle, ORC, was established as a combined heat and power system in the sector of palm oil mills by employing EFB of palm oil. The basic ORC system's configuration as a starting point and an ORC system with a regenerator. The system used an expander to use the energy in the organic working fluid for power generator and an AFP direct fired biomass thermal oil heater TOH. Unit to transfer heat from fuel to the organic working fluid. The ideal Rankine cycle and the ORC operate on the same principle. Instead of water, an organic substance with a low boiling point is used in ORC operation. Hence, lowering the temperature is necessary for evaporation. For operation make up a basic ORC, pumping up the working fluid pressure, adding high temperature heat through a boiler, expanding high temperature and high pressure fluid through a turbine, and rejecting low temperature heat through a condenser. Below is an example of Rankine cycle, superheated Rankine cycle and reheat Rankine cycle. So the working concept is there is 4 points in this Rankine cycle, where the point 1 is the organic fluid that is inserted into the pump where the condition is fully liquid. At point 2, the pump will compress the fluid in order to transfer the fluid to the boiler. Thus, the state of the organic fluid at that point is compressible fluid. There is no compressible data inside the thermodynamic table. However, there is work done by the pump. Thus, using the work formula, we calculate the pressure at point 2. W equal to velocity P1 minus P2. And work also equal to enthalpy 2 minus enthalpy 1. At point 3, at this point, the boiler heating the organic fluid until the organic fluid overheating, which make the organic fluid is in a state of superheated, which make it fully vapor and go to the turbine. At point 4, when the vapor is inside the turbine, the shaft of the turbine that connect to the generator will rotate because the vapor move the turbine fan. At the same time, the temperature of the vapor will decrease until the organic turns into mixture. However, the entropy of the fluid remains the same, S3 equal to S4. When we get the enthalpy at each point, we can calculate the mass flow rate, power, and thermal efficiency of the system. The formula as below: heat energy inlet, heat energy outlet, power, and thermal efficiency.
Next is technology of biomass. Malaysia has spent the last 40 years as one of the top producer and exporters of palm oil in the world. Along with crude palm oil, CPO, and palm kernel oil, the palm oil business also generates palm shell, pressed fiber, empty fruit bunches, EFB, palm oil meal effluent, POME, palm trunk used for replanting, and palm foods during pruning. In the processing of fresh fruit bunches, over 70% of the volume is discarded as waste. About 4 million hectare of land in Malaysia are used for oil palm plantation. Just four states, Sabah, Johor, Pahang, and Sarawak, have more than 500,000 hectare of land under cultivation, accounting for more over 75% of the entire area planted. Fresh fruit bunches FFB processing volume was anticipated to be 75 million tons, while the FB production volume was estimated to be 16.6 million tons. Malaysia produces over 58 million tons of POME annually, which has the capacity to generate about 50 million M3 of biogas annually. Another significant agricultural biomass resource with strong potential for power cogeneration in Malaysia is rice husk. The biomass power plant in the state of Perlis, which uses rice husk as its primary fuel and generates 10 megawatt of power to cover the needs of 30,000 homes, is an example of its appealing energy potential. Okay, this is a design of system. The design of EFB palm oil power plant is based on Rankine cycle. The assumption can be made on the design is that the system is a closed system. The pump and the turbine is an isentropic process, while the boiler and the condenser is an isobaric process. The assumption is made so the cycle of the system is an ideal Rankine cycle. It is designed that reheat process is used to increase the efficiency of the entire process, since reheat and can make sure that the fluid going to the low pressure turbine was fully vapor. The first stage was the pump will be compressing to fluid to the boiler. The second stage where the fluid was heated, so the vapor will continue to flow to the turbine. The third stage is where the vapor was gas will flow into the high pressure turbine and move it, and then the vapor gas split into two ways, where the first one will return to boiler and the other one will continue to flow through the next turbine, which is the low pressure turbine. The fourth stage is the fluid will rotate the low pressure turbine, and the generator will start generate the electricity. The fifth stage was the vapor gas will flow to the condenser, where fluid will become water vapor mixture. Finally, the last stage is when the fluid flows and join the other to be compressed by the pump, and the cycle is completed. Okay, this is our design of 5 megawatt power plant. So the the question is to consider a steam power plant that operates on a Rankine cycle and has a net power output of 5 megawatt. Steam enter the high pressure turbine at 10 megapascal at 500 degrees Celsius and the low pressure turbine at 1 megapascal and 500 degrees Celsius. Steam leaves the condenser as a saturated liquid at a pressure of 10 kilopascal. The isentropic efficiency of the turbine is 80% and that of the pump is 95%. The assumption is water is as a working fluid, no potential and mechanical energy. The steam is superheated at high temperature. Assume adiabatic condition at boiler and condenser, present at heat loss at pump and turbine. So this calculation, we find the possible value every stage from the diagram from the value that have been initialized. First one at the point 1, which is the pressure 10 kilopascal, and then for state 2, we use work pump V1 times P2 minus P1 and H2S equal H1 plus work pump to find the value of enthalpy. For state 3, we can find the value in the table and for state 4, we can find the value needed related to state 3, which is S4 equal to S3 and equal to 6.5995 kilojoule per kilogram times Kelvin. For this value, we can find the relation of these two states and find all the value for state 4. State 5 is same as the state 3 as the value of pressure and temperature are given and continue looking the value for state 6 like from the report. Lastly, as all the value from all the state are known, we find that the heat input, heat output, the net work done, mass flow rate, and thermal efficiency respectively from this formula below.
For potential of biomass energy in Malaysia, since Malaysia began implementing the four fuel diversification strategy in 1980, which sought to balance the use of oil, gas, coal, and hydro in the energy mix, renewable energy in Malaysia has come a long way. The fifth fuel policy was signed in 1999, while the Kyoto Protocol was signed in 1997. Malaysia vowed to reduce its contribution of greenhouse gas emissions to its gross domestic product (GDP) by 45% in 2030 relative to 2005 at COP15 and to cut its carbon emission by 40%. So biomass has tremendous potential for co-firing conventional power plants, which typically use coal or natural gas, as well as for pelleting conversion process. There are several advantages and disadvantages for to using garbage to generate electricity. Reduce emissions of carbon dioxide, sulfur oxide, and nitrogen oxide, which can lower the amount of greenhouse gases, are only a few of the environmental advantages of co-firing. In addition, if this technology is appropriated and practical for deployment, it can provide other advantages like energy security. This is because, unlike coal, which is primarily imported resource from Malaysia, some of the fuel may come from local source. Discussion. So, biomass power plant can generate between 2 to 1,000 megawatts of electricity. Though most swings of from 2,000 megawatt to 200 megawatt. To put this into perspective, 20 megawatt is enough to power around 15,000 to 2,000 homes for an hour. So for our palm oil power plantation can produce 5 megawatt. For day in Malaysia, average home will use around 22,440 watts per day. So for our power plant, it can power around 250 homes for the daily use for a day. So one of the benefits of this biomass power plant is it is renewable energy. This is because there are plenty of sources of biomass that can be used to create this energy. Right? We can also create that source as we can do replantation for palm tree. So as for the disadvantage, it needs larger space to add the source. So if we have to replantation, we need another space. So as I mentioned, we know that Malaysia is one of the small countries in this world. So our land are limited. So below that is a statistic of household power use in Malaysia from 2002 to 2016. So for the conclusion, to sum up this report, we believe that biomass industry has a potential to become one of the source to provide energy in the future because biomass can recycle the emission that it produces, and it can be used to generate heat, which can generate more energy. So other than that, based on the additional energy that so the less material biomass used will generate more electricity. We also know that biomass material that burn are sustainable energy source that derive from other extinction or active organism. So this will have no effect on the environment. That's all from us from group 5.